So we'll start by going through the solutions to the transformation sheet. So the first thing that I would do is we're going to list the values for A, H, and K, and then use those values for A, H, and K to describe the transformation occurring. So to figure out the values for A, H, and K, I'm going to use that general form for a function. So if I look at number 1, I see the A is 1, the H is 0, and the K is 6. There's a question? So I'm using this, and then I'm looking at that. Okay, so if I'm looking for an A, do you see anything out front? No. So what number can you multiply by something so that it doesn't do anything? 1. So that's why the A is 1. Then I'm going to look on the inside here. So I don't see minus anything. What number can you subtract and it doesn't do anything? 0, so the H is 0. And then I look for the K here at the end, and I can see that that's 6. Is that okay, Justin? Okay. So what I'm going to do now, after I figure out my values for A, H, and K, is I'm going to use that list of 4 criteria that we discussed last time. You guys remember criteria from last time? So I'm going to label things 1 through 4 and indicate whether that if 1 is happening, 2 is happening, 3 is happening, or 4 is happening. Okay with that? Yes. Oops. Okay. So, stop talking, please. If I look at 1, 1 is concerned with whether A is positive or negative. Since A is not negative, that doesn't do anything. So I'll just put a little dash there. 2 is concerned with the magnitude of A. Since the magnitude of A is still 1, that doesn't do anything. 3 is concerned with the value of H. Since the value of H is 0, that doesn't do anything. And 4 is concerned with the value of K. Since K is non-zero, that does something. Since K is positive, it's going to move it up. And since K is 6, it'll move it up 6. Let's look at number 2. What is my values for A, H, and K for number 2? 3, 2, and 0. Very good. So again, number 1 is concerned with the sign on A. Since A is positive, that doesn't do anything. 2 is concerned with the magnitude of A. Since the magnitude of A is bigger than 1, this is a vertical stretch. 3 is concerned with the value of H. Since H is positive, it's going to go right. And since H is 2, it's 2 units to the right. And then 4 is concerned with the value of K. Since K is 0, that doesn't do anything. For 3, what is the value for A, H, and K? So does 1 do anything? Is concerned with the sign on A. Since A is negative, 1 does something. What 1 does is it's a reflection across the x-axis. Does 2 do anything? No. 2 is concerned with the magnitude of A. Since the absolute value of A is 1, 2 doesn't do anything. Does 3 do anything? Yes. 3 is concerned with the value of h. Since h is negative, we're going to go left. And since the value of h is 3, it'll be left 3 units. 4 is concerned with k. Does 4 do anything? Yes, since k is negative 6, it's going to go down 6. So the negative tells me the direction, and then the value tells me how much. Looking at 4, what's my value for A? 1/2. The value for H? Negative 3. And the value for K is 0. Tommy, it's negative 3 because there's a subtraction symbol in the formula.
Oh.
So if I plug in negative 3, x minus a negative is plus. So the h's are always the opposite of what they appear. Okay? I'm glad I doubled that answer up. That's efficient. 2 questions for the price of 1. All right. So, number 1, did that do anything? No, because the a is not negative. 2, does that do anything? Yes, because the absolute value of a is not 1. Since the absolute value of a is less than 1, it's going to be a vertical shrink. Does 3 do anything? Yes. Since the value of h is negative, it's going to go left. And since the size of h is 3, it'll be left 3. Does 4 do anything? No. Since k is 0, nothing happens. And the last one, a is good, h is good, and k is good. Everybody happy with that? For 1, a is negative, so we have that reflection. For 2, the magnitude of a is greater than 1, so we have a vertical stretch. For 3, h is positive 9, so we're going to go right 9. And for 4, k is positive 1, so we're going to go up 1. So again, this list from the last notes, 1 through 4, should you know these? Absolutely. Yes, Nancy? Correct, and we wrote vertical stretch. When the absolute value of a is greater than 1, we have a vertical stretch, which is what we wrote, because the absolute value of 3 over 2 is greater than 1. Yep. Okay with that? All right. For 6, 7, 8, 9, and 10, I'd begin kind of the same way. I'd identify the values of a, h, and k for each of these. So let's do that right quick. And what I'm going to be doing now is I'm going to use my transformation map that we presented to you guys in the last notes. So I'm going to use this transformation map to do these transformations, and then I'm going to collect the ordered pairs and just plot them to get my new graph. So I'm going to be using this to do these problems 6 through 10. Okay? So should you have that memorized? Yeah. Okay. So okay. So what I'm going to do is I'm going to collect the ordered pairs graph. So I see that there are 5 ordered pairs labeled on my graph. I'm going to write those down. Is that 2 or 3? It's 3. Everybody's okay there. Now I'm going to do, for these 6 or 5 ordered pairs, I'm going to perform the transformation described in 6. So I'm going to fill in my values for A, H, and K for 6 into my transformation map. So x plus 0 is x, 1 times y is y, and then I have the plus 1. Everybody's okay there? And now I'm going to perform that transformation on each of my xy's. So negative 1, I plugged in for x. I plugged 0 in for y. 0 plus 1 is 1. Negative 0.15 is x. And then negative 3.08 plus 1 is negative 2.08. Plug 0 in for x, and then 1 plus 1 is 2. Plug 215 in for y. 3.08 plus 1 is 4.08. And then 3 in for x. 0 plus 1 is 1. Which one? So I took my values for A, H, and K from number 6 and plugged them into this formula. So I have x plus 0, comma 1 times y plus 1. X plus 0 is just my x. 1 times y is just my y, and then I just have the plus 1. Is that okay? So all I would have to do now is plot these 5 new points and draw my graph. Is it okay to omit plotting the points and drawing the graph? Do you guys feel comfortable plotting points and drawing? Okay, then let's move on and do 7. So just like I did in the first one, I'm going to write my formula for my transformation. So I have x plus h. So in this case I have x plus 2. Then I have a times y, that's 1.5 y, plus k plus 0, so I need to write the plus 0. So when I plug negative 1 in for x, I get 1. When I plug 0 in for y, I get 0. When I plug negative 0.15 in for x, I get 1.85. And when I plug in negative 3.08 for y, I get negative 4.62. And continuing on, I get 2 comma 1.5. Okay. I copied this point down wrong. excuse me. That was 1, 0, not 0, 1. Shame on you guys for not yelling at me about that. The shame! I know. There we go. All right, and then finishing this up. So 4.115, and then positive 462, and then 5, 0. So far, so good. Get the idea here. Okay, let's do 8. So I have x minus 3, negative y minus 2. So I'm going to have negative 4, negative 2. Negative 315, comma, negative 5.08. Oops, that's not right. 1.08. Negative 2, negative 2. Negative 0.85. And then 5.08. Negative 5.08, excuse me. And then I have 0, negative 2. For 9, I'm going to have x minus 4, 1/2 y, and then plus 0 doesn't really matter. So I'm going to have negative 5, 0, and then negative 4, 15, comma, negative 1.54. And then negative 3, 0, and then negative 1.85, positive 1.54, and then negative 1, 0. And then my last one for 10 is x minus 1, or x plus 1. Negative 3 over 2y plus 2. So that's going to give me 0, 2. And then 0.85. And then 6.62. And then 2, 2, and then 3.15, and that would be a negative 462. So negative 2.62. And lastly, we have 4, 2. So again, the part of this problem that we didn't do was plotting the points and drawing in the curve. You guys sounded like you're pretty okay with doing that part, so I omitted that in the interest of time. Questions from this sheet? So you saw, again, from the last lecture, the two big important pieces that we used over and over and over again was this list of 4 criteria to decide what the A, H, and K did. And then this transformation map as an easy way to generate the transformed points of a function. So those were the two big pieces there. Yes, Justin. Of course. Okay. Moving on to the review. Sound good to you guys? Okay. Would you prefer to just go straight through and do as much as we can, or would you rather jump around? Okay, that being said, I promise you we're not going to end up with enough time to finish going through the whole thing. So if you pick straight through, there's going to be stuff at the end that possibly we don't get a chance to talk about. That's fine. I just want to be clear about like what we're in store for. Okay? If you guys change your mind, let me know. Okay, so if I look at 1, it asks us to give an example of a relation that is not a function and a relation that is also a function in each of the following forms. So the first form it asks for is a mapping diagram. What does a mapping diagram look like? It's the thing with the 2 circles. Good. So I'm going to label one of them as domain and range. So I just picked D and R. Everybody's okay with that part? Okay. And inside of these circles, we should list some numbers, right? Does it matter which numbers we list? Not really. What's the one thing that you can't have? Yeah, you can't have a repeat. So I can't write like the number 1 more than once. So maybe we'll just write the numbers 1, 2, 3, 4, 5, 6. Sound good to you guys? All right. So let's say the first one we're going to write is the function one. What should the arrows look like for this first one? Okay, so for example, where do you want 1 to go? 6, okay, and then what about 2? Okay, and 3? Okay. Can we have 1 go to something else also? Not if it's a function, right? Did we have to connect 1 to something? Yes, if it's going to be a function, we do. So this is an example of a function. Each of the things in the domain, they all go someplace, and they all only go to one place. If this one is supposed to be not a function, there's 2 ways that you could do that. What's one way? Katie? Okay, so 2 arrows coming out of one domain. So like, for example, if 1 goes to 4 and 6, that's not a function. Everybody's okay with that? That's one way you could do it. What's the other way? It's to not use one of the domains. So for example, if I had this where 3 doesn't go anywhere, that's also not a function. Everybody okay there? Okay. Can I erase these? All right. I don't know if people were copying. I didn't want to cut anybody off. Next one is a set of ordered pairs. What does that look like? Yeah, just kind of like that, right? Like that number 7 down below. Okay? So does it matter how many ordered pairs that we have? Not really. Let's use 4. So let's say the first one that we'll list will be the function, the second one will not be a function. When listing the first one, what do I have to make sure that I'm careful about if I'm writing a function? Don't any x values. Does it matter if the y values repeat? No, that doesn't. So I can just pick whatever x values, right? Everybody's okay with that? So the one that is not a function, what does it need to have? Repeating x values. So maybe I just switch those first 2 coordinates and keep everything else the same. And that's not a function. Everybody okay there? May I erase? When I say that, if you're still writing, just be like, no! And that's fine. We can wait. But nobody answers, I assume it's okay to erase, though. So if you're like, I was still writing that, shame on you for not speaking up. Speak up next time. I'd be happy to wait. It's much harder to unerase than it is to wait. All right, next one is graphs. So when looking at a graph, what's the important thing to tell if it's a function or not? Vertical line test. So all I got to do to write something that's not a function is write something that fails a vertical line test. Is that hard to do? No. You can draw like almost anything you want, right? Does that fail a vertical line test? Oh, buddy, it does. All right. So that's our not a function. Our function needs to pass that vertical line test, so we draw something like that, right? Doesn't have to be like super pretty or like mega complicated, just, you know, it could be really trivial. And you could do this. Like, doesn't have to be fancy. That works. Pass the vertical line test. Okay with that idea? Anybody still drawing graphs? Okay. The last one is equations. Can somebody give me an equation for a function? Harley? Great. So y equals 3x plus 2. Really anything of the form y equals mx plus b would work. Because what is the graph of y equals mx plus b? Just like a diagonal line, right? Those will always be functions. That's great. Does anybody remember an example of an equation that's not a function? Caden? Good. X squared plus y squared equals 1 is not a function. Remember we talked about that this was the graph of a circle. It was kind of our example, our standard example of something that wasn't a function. There's obviously lots of other answers there, but that was kind of the obvious one that we'd used a couple of times, I think. Justin? Okay, so that's kind of getting into the next set of questions. So can I just hold that off? Because we deal with that several times, I think, in 2 through 9. So I'd be happy to answer that. How do I tell if an equation is a function or not? But let's do it inside of some of these examples on 2 through 9. Fair? Okay. So on 2 through 9, we're going to determine if it's a function, justify our answer, and then write down the domain and range. And the first one here. So if you look at that, is that a function? Maybe it's not really totally obvious straight away, right? Would it be easier to tell if it was a function if you could look at its graph? Yes. So let's do that. What I'm going to do is I'm going to rewrite this to get the y by itself so I can type it into my graphing calculator and look at the graph. Sound good to you guys? So I'll subtract 4x from both sides and then divide both sides by 2. And then I'm going to graph that. Once I have it in this form, does anybody change their mind about whether this is a function or not? Yeah, you probably have noticed that that is y equals mx plus b all over the place. That should be a function. But if you didn't, that's fine. We'll just type that equation into our calculator. So I did negative 2x plus 4, and then just did zoom standard. And we get this nice diagonal line, which definitely passes a vertical line test. Everybody agree that this is a function? Justin, are you okay with that method as to like how I could figure out if one of these equations is a function or not? So in terms of justifying your answer, if you were to say, what could we say to justify this? Anybody is fine. Doesn't have to be you per se. Okay, if you want it, so Kane says you could say it passes a vertical line test. Perfectly reasonable. If you were to do that, I'd want to know the equation that you graphed and like a sketch of the picture that you used and then like some evidence that you checked the vertical line. And then you can say pass the vertical line test. That's perfectly reasonable. So I should be able to see what it is that you graphed, what that picture looked like, and then that it passes a vertical line test. Perfectly reasonable explanation. Everybody's okay with that? What else could you say? Nancy? Yeah, so if you said that this is in the y equals mx plus b format, and it's a linear function, that would be fine. Perfectly reasonable explanation. So either of those is fine. Those are probably the two that I would expect to see. Would be one or the other of those. Questions about, we still have to do the domain and range though. Okay. So if I look at the graph, that's probably going to be the easiest way to determine the domain and range. So let's look at the graph on my calculator there on the right-hand side of the screen. So let's do the domain first. To do the domain, I should find the leftmost point. Is there a leftmost point for this graph? So there's not, right? Anytime I can pick a point on the graph, there's always something else to the left of it because the graph is continuing to go on forever to the left. Everybody agree with that? What symbol am I going to write then as my lower bound? Negative infinity. Because it's on the left side of the graph. That's where the negatives live on the x-axis. Then I'm going to find the rightmost point on my graph. Is there a rightmost point? No. What should I write here? Positive infinity. And I remember that all infinities get parentheses. And that's the domain. Let's do the range next. To do the range, we're talking about the y's, so we're looking up and down. So let's find the lowest most point on my graph. Is there a lowest point on this graph? No, right? Because it's going down forever. What should I write then? Negative infinity. Very good. And then we'll find the uppermost point. Is there an uppermost point on this graph? No. So what should I write then? Positive infinity. So there's the domain and range for number 2. And again, this was massively easier looking at the picture, right? So on any of these where you're given an equation, my first step would be to use my calculator to get the picture. Justin, that feel better? Okay. Let's look at 3, which is this graph here. Is this a function? No. Why not? You could just say it fails a vertical line test and draw an example of that happening. That would be perfectly fine. Everybody happy with that? You can absolutely use that abbreviation VLT. I'm happy with doing that. Any abbreviation that I use in class, unless I tell you you should use this abbreviation, you're free to use. Okay, let's do the domain and range. So the next, to do the domain and range, let's do the domain first. We need to locate the leftmost point on the graph. That looks like it's this point right there. Everybody agree with that? If I track that up, that looks like that's the x-coordinate -1. Then I'll find the rightmost point on my graph there. If I track that up, that looks like it's the x-coordinate positive 3. Everybody okay with that? Should these have brackets or parentheses? Good. Brackets for each of them. The reason is because there is actually a point on my graph that has the x-coordinate of -1 and the x-coordinate of positive 3. Those are actually points on my graph. Everybody can see that? Okay. Let's do the range now. So we'll start by finding the lowest point on the graph. That's here at 1, -5. And the highest point on our graph, which is here at 1, -1. So my range goes from -5 to -1. And these also get brackets for the same reason. Questions about 3? Okay. Let's look at 4. Is 4 a function? No. Okay. Why not? Okay. Let's be a little bit more specific about 1. Let's say x equals 1 is used twice. The reason I want to be more specific is that 1 is also used twice as a y-coordinate, which is fine. Our problem with it being a function is that 1 is used twice as an x-coordinate. So I just want to make sure I'm specific there, because if you just say 1 is used twice, the reader isn't sure whether you're talking about x's or y's or x and y's or exactly that. So just be a little bit careful about being specific there. But absolutely the right idea. You're just looking at the x-coordinates and looking for a repeater. The domain, how many x's do we have? 4, so we can just list them. 1, 2, 3, and 5. Notice that even though 1 occurs more than once, I don't write it more than once. And similarly with the range, 2, 4, 1. So I can just list those values since they are finite. Everybody okay with that? Of course. Let's take a look at number 5 then. Is 5 a function? No. Good. Why not? Good. So you could say that, or we could just be specific and say x equals 1, for example, is used twice. Everybody okay with that idea? Or you could have picked 5 or 10. Any of the x's are used more than once in that specific example. So any x you picked as your example as to why it's not a function would have been fine. And then the domain, well, there's just 3 x's. And there's just 2 y's. So we can just list them using that finite set notation. Okay, let's move on and take a look at 6. So, 6 is an equation, right? I'd suggested that maybe the easiest way to deal with this kind of thing is to type this into our calculator and look at the picture. How would I do that, though? Because this has a plus or minus. has a plus or minus in the problem. I don't have a plus or minus button on my calculator. How do I deal with that? Well, it's easy. All we're going to do is type it in as 2 lines on our calculator. So I'm going to type in x plus 1. Oops. X plus 1. And I'm going to type in x minus 1. And the graph that I'm going to get is going to be the graph for x plus or minus 1. Everybody okay with that plan? So I'll do zoom standard. So the graph of x plus or minus 1 is this set of parallel lines. Everybody okay with that? Is this a function?
No.
No, right? Why not? Yeah, it fails the vertical line test all over the place, right? Y equals x plus or minus 1 is this pair of parallel lines. Anywhere you draw a vertical line is going to intersect this twice. Does that make sense? But in order to say fails a VLT, what would you need to show me? Yeah, you'd have to just sketch me a picture of the graph from your calculator where you're showing it failing a vertical line test. Which I think is not too high of a bar, right? That seems reasonable. Okay. Let's do the domain and range then for this. Is there a leftmost point? Is there a rightmost point? So my domain is negative infinity, positive infinity. Is there a lowest point? Is there a highest point? So the domain and range is the same as number 2 was, right? Everybody feel okay about 6? Justin, you feel better about these equation ones? Okay. So again, that hack of like using your calculator to just look at the picture typically makes life much easier. All right, 7. Is this a function? Yes. Why can we say it's a function? Yeah, so you can just say no x values repeat is fine, or use more than once is fine. Yes, sir. Of course. And then the domain, since there's a finite number of them, we can just list the x's and list the y's. Again, when we do that, though, you have to make sure that you're not repeating or listing any repeats. Let's look at the mapping diagram there for number 8. Is this a function? Yes. What would I say is my reason why? Okay, so when you say they, let's be specific. Good. So all the x's are used once and go to one place. Perfectly reasonable explanation there. Good. Everybody happy with that? Okay. The domain. Just list them 1, 2, 3, and the range. I think that's 21 is what that says. It's awfully blurry. I can't tell. Everybody happy with 8? Okay. Last one, let's look at 9. Is 9 a function? Yes? what would we say is our reason? Yeah, passes the vertical line test, and again, drawing a couple vertical lines just to show me that you checked. And I'd call that good enough. Let's do the domain and range now. Is there a leftmost point? No. Is there a rightmost point? No. Are we happy with that? Okay. Is there a lowest point? Yes. Like here or here, they look like they're the same low. So if I read their y-coordinate, that looks like a -4. Is there a highest point? No. So put a positive infinity there. So the question is that -4 should get a bracket or a parenthesis? Bracket. Why? Because there is literally a point that has that y-coordinate -4 on it. Everybody agree? Okay. Let's look at the next one here. So on number 10 here, we're asked to write the domain and range, the intervals of positive, -0, increasing, decreasing constant, and the end behavior. Does this graph look familiar? It's literally the graph from 9. I just made it bigger and labeled some points on it for you guys, but it's the same graph as you saw in number 9 there. So we have our domain and range already. We just did that. Notice here that I gave a little bit more detail. So instead of writing -4, I'm going to write -4.05 because here I've labeled what the bottom of that, or what that lowest point's y-coordinate actually is. Before, we were just estimating it off the graph, and -4 is a perfectly reasonable estimate based on that picture. Everybody okay? There. Okay. Next up, let's do the positive, -0 part. So the positive part of the graph, from there to there, there to there, and there to there. And the negative parts of the graph are right there and right there. Does everybody agree with that? So if I do the positive parts, I have -infinity, -4, -1 to +2, and then 5 to +infinity. Hi? Of course. And then my negative parts then are -4 to -1, and then 2 to 5. And my zeros, there are exactly 4 zeros, so I can list those just as a finite set. I don't have to use an interval notation there. Is everybody okay with what I did there? Okay, I'm going to erase my marks and remark this up for the increasing, decreasing constant. So I am decreasing from like there to there, and then from like there to there, and then increasing everywhere else. Everybody okay with that idea? So my increasing goes from -2.85 to 0.5. And then again from 3.85 to positive infinity. And then I'm decreasing from negative infinity up to negative 2.85. And then 0.5 to 3.85. Everybody okay there? And there's no constant parts of this graph, obviously, right? There's no flat sections. So the last thing is to write the end behavior. Remember, the end behavior is describing what the ends of the graph are doing. So my left end points up. So left is x approaches negative infinity, and up is y approaches positive infinity. And then my right end points up. So right is x approaches positive infinity, and up is y approaches positive infinity. So again, for the end behaviors, the left and right is described by the x, and the up and down is described by the y. Okay with that? I'm going to skip 11 because it's doing the same thing as 10 in the interest of kind of moving along. Do we need to review how to find these extreme on the calculator? Huh? Yep. So go to y equals. Type in our equation exactly as it looks after I've cleared out all the rest of the stuff. Then I'll hit zoom standard to graph this. I see one local minimum and one local maximum. To find one of them, let's say we'll find this local minimum, and press second and the trace button. From this list of commands, if I'm looking for the local minimum, I should pick the minimum command. And now it's going to ask me 3 questions, left bound, right bound, and guess. So the left bound I want to pick anywhere over on this section of the graph, left of where that minimum is. So I'll move my cursor over to there. That looks good. I'll press enter. Now for the right bound, I want to pick anywhere on this section of the graph. It doesn't matter where on that section, anywhere on there will do. So I'll just move my cursor over somewhere over there. That looks good. I'll press enter. The guess doesn't matter. I'll just press enter where I'm at. So my minimum is at negative 1.4305, comma, negative 3.380179. To do the maximum, we do exactly the same thing, except we use the maximum command. Harley? Of course. Any questions on the calculator ones? Again, if you can't remember how to do these things on your calculator, go back and watch the video again. You'll see me button pushing through and discussing how to do it again. That's often helpful to just rewatch it, follow along by hand if you're still struggling with those. And the last questions are similar to what you guys did in the previous homework assignment. So we're going to identify the transformation. So for 14, I'd start by identifying our values for A, H, and K. What is my value for A? 2. My value for H? Positive 3. And for K? Negative 2. So then I make my list 1, 2, 3, 4. So what I'm using, Tommy, is I'm looking at my list of criteria from last time to do the number 1. I'm checking to see if A is less than 0. In our case, A was not less than 0, so nothing happens for 1. For part 2, I'm checking the absolute value of A, and if it's equal to 1. Ours is not equal to 1. In fact, it's greater than 1, so I have a vertical stretch. Our H value is, I forget what it was. It was positive, though. It's not 1, so it's going to go right that many. And our K value was negative, so it was going to go down that many. Correct. Yeah, if the H or K is 0, nothing happens. And if the A is 1, nothing happens. So we said nothing, vertical stretch, right 3, and then 2. Are we okay on that? So here again, I've given you a graph of a function and asked you to graph its transformation. Again, just like we did in last night's assignment, I'd start by identifying my values of A, H, and K. And then I'm going to use those values to create a transformation map. And then apply that transformation map to the ordered pairs in my function. So here, if I subtract 2 from the x's and add 3 to the y's, subtract 2 from the x's, add 3 to the y, subtract 2 from the x's, add 3 to the y, and then I could plot this. So negative 6, negative 2, 0, 4, and then 2, 2. So that's a graph of my new transform function. If you look at this visually, it looks like it's been moved left 2 and up 3, which is exactly what we'd say based on the values of A, H, and K. Okay with that one? So again, just like last night's assignment that we went through at the beginning of class, that gives us, at least we've gone through one of every type. Are there last minute questions here?